So, Randal Schwartz back again with another tip or trick or technique around Dart and Flutter. Today I'm going to cover some new things in Dart 3. Dart 3 was just released very recently as I tape this, and I was going through the website, the new website for Dart and Flutters, Dart and Flutter, trying to see what had changed. I've been watching the online repos for those as well and trying to help out where I can. But one of the things that was added was a really wonderful little Codelab on the using records and pattern matching now that those are available in Dart 3. And as I was looking through the example for that, I thought, oh, they're doing something a bit interesting and maybe not even the way I would do it if I started from scratch. So I want to talk about their way of doing it and my way of doing it. So the key element here is that we have this code, which is primarily taken directly from the Codelab. I cut and pasted it, so I'm pretty good at that. I cleaned it up just a little bit to make it easier to see here. So I have the goal of this part of the code is to take this JSON and extract a couple of elements out of this metadata element from it. Later on, they go in and add more code that actually decodes these blocks down here, but we're not going to look at that. We're just going to look at this part here. So I want to get the string that's a title. I want to get the string that's actually a date and parse the date. And if you've done the Codelab, this will be really familiar. If you haven't done it, I hope I'm not giving any spoilers away. So pause the tape, go off and do the Codelab, and come back if you need to. Pause the tape. How old am I? Okay, so inside there's this class called document. That's something I took from them. And they're creating a member here of JSON, a property. And it's going to come back from JSON decode. Now, JSON decode is really wonderful in that it parses JSON, but it returns it as a strongly typed data structure, but it can be variable in data structure, so it gives it sort of a compile time type of just dynamic. Well, dynamic for smart people is object question mark, so I called it that here. So JSON coming in is going to be an unknown object. We don't know what it is. It could be a map, it could be a list, it could be a simple value like a number or a string or a bool or null, lots of different things it could be. So we don't know yet what that is. But we want to extract the data from it. So here's how we do this. We're going to call get metadata, which you'll see up above here. We're eventually invoking on this. And get metadata is going to be returning, oh look, a record. A record of both the string, which will be the title, and a date time of modified. That would be a little tricky to do with pre-Dart 3 code because we would have to return a list of two things or have to return an object. And here we've just got like a ad hoc object that has these two items in it, strongly typed. Metadata is going to then process the JSON that is the property of this thing. Now, at this point, JSON is still object question mark. We don't know what it is yet. So what I'm doing here is I'm saying first, I'm claiming it's never going to be nullable. Ha ha. It could actually be that the actual JSON string was null, at which point this will blow up, because that would be the wrong thing for that. But let's just presume that I know I'm only going to decode things that are not nullable, and I know that I'm only going to decode things that are string dynamic. Now, map of a string dynamic. Now, those are both promises to the compiler that I believe that when I run this code, _JSON at this point is definitely a non-null value, and furthermore, it's a map of string dynamic. Now, what happens if those promises are not kept? Dart will blow up at this point, but that's exactly what I wanted to do. That's how I'm going to read this. Okay, and I'm putting this into a local variable. And because of my video on the devious coin, you may understand why I'm doing this here. This is a property out here, and even if we promote it to be non-nullable, it could still be overridden. I make a local variable, and that solves it. If you don't understand what I mean, go back to my other video on look for devious coin in the title and about nullable promotions. But this makes it guaranteed at this point, if we're still running code and not thrown an exception at this point, then we are now have a map of string dynamic. Now, the rest of this code is just the traditional way of drilling down through JSON. And if you've done any kind of work with APIs or with Firebase, you've had to do this sort of work. You get this sort of tree of lists and maps, and you have to figure out what each layer is and do a lot of extra horsing around, including things like this, where you have JSON, you say metadata. Well, guess what? Metadata JSON there is dynamic. It still doesn't know what type it is. It only knows that JSON is non-null and that it's a map, so it goes ahead and lets this part of it happen. Oh no, sorry, that's because of this contains key. I skipped right over that. So JSON we know this is non-nullable, we know this is a map, so we can use contains key at this point and see if that key is actually there. Now, that means we can go ahead and use JSON metadata, but again, like I said, we don't know what it is yet. We know that it is dynamic. That's all we know. That means the compiler couldn't figure out at compile time what that might possibly be, so we're going to have to rely on runtime upcasting. So the first step to that is we're going to say metadata is map. That's going to return a bool that will tell us whether that's a map or not. Okay, and if it is, then we're hopefully in the right shape of data. Now we can drill down and we pick out title. But again, that's going to return dynamic. So this expression right here is dynamic. And we know it's a string, or it better be a string. And in fact, we're promising to the compiler this is going to be a string at runtime. And it is free to throw up an error if that's not true. So you'll see that pattern repeated a lot. And now this other one's a little trickier. We've got local modified. Now that's going to take the modified element back from the JSON down here, the modified element with the date. And it's going to again declare that we know will be a string. So it's going to be present. It's going to be a string. We're happy with that. We do date time parse on that, and we pick out the actual date time that's related to that. We then return, and here's our record structure, record constructor of the title and the modified. That comes back as our two elements up in the top of this function. Where was that? That's right here. Okay. So get metadata, returning this list. If the ifs fail, if any of the ifs fail, we don't get down to the return. And instead, we fall out of the bottom of the if, and we throw. We throw a format exception of unexpected JSON. Okay. So this thing has multiple ways to blow up. It can blow up as an exception up here because we don't have the right shape of the top level of data. It can blow up because some of these conditions aren't fulfilled. It also can blow up if the parse fails. But I'm going to ignore that for a second because that's in the weeds at this point if things blow up. Okay, so this works. We can go up here, invoke run, and out it comes. There's my document, and there's the parse time down here. This is the before of the before and after pair that are in the current Codelab. So let's go to the after of the before and after pair to see how they solve this with pattern matching, or at least simplified some of it. Most of this stays the same, so I'm not going to go through the rest of this. Again, JSON decode, again, it's object question mark. We haven't changed any of those. But now what you'll see in get metadata is that we have an if JSON. But what's that? Well, it's actually an if pattern match. And we can tell it is because it immediately has the word case in here. And case means that we're going to give it a list of cases like a switch. And in this case, there's only one case ever allowed. We give it the case, and it's going to try to do a pattern match on the value. So the pattern here is if it is a map, and if the map has a key of metadata, and if the key to metadata is also a map, and if that map has a key of title and a key of modified, it extracts with these types the corresponding values. Now this is typed, which means that if these aren't strings, this will blow up. Now why might they not be strings? Well, maybe that was a value in the JSON that was a number or a bool or a null. All of those would have been possible, but this guarantees that we have a map with metadata that points at a map with title and modified, and those two values are now extracted. Wait, how did that happen? Well, when we put final string title in here, it creates a brand new variable called title that we can reference. We reference it right down there. And the same thing with local modified. That's also a string, and we reference it right down here. Wow. So if the if statement is true, if we're going to take the true branch, which starts right here, then we're going to return this title that was in, we're still in scope of that, so we can still see it. And we're going to do the date time parse on parse modified. Now notice that the record actually is one positional element and one named element. Just to be weird, I think they did this to show off all sorts of cool things. So we have a one positional and one named element. Okay. Now, so if we have exactly the right shape, we've extracted the data and done that. If you haven't seen this yet, this should be pretty excited by now, because look how much simpler this is than the previous code we just had. Okay, because we just kind of spell it out, almost looking like we're making one. So that's really the nice thing about patterns. Okay, now, if the if statement doesn't match, if the if switch doesn't match, then we go to the else branch. And the else branch here is throw, unexpected JSON, once again. So that's another way out of this function call. And we might end up throwing an exception as one of our exit paths. Okay, now, because the value we're returning is this record again, we need to extract it out. And once again, we're going to see metadata, $1 is the first parameter of the metadata, and modified is the named field of that record. So we end up with $1 and modified. Wait, was that the same way in the previous one? And I didn't go through it. I'm sorry. So yes, I didn't go all the way up to here on the previous version, but that part didn't change. Okay, so we've got string, datetime modified is our return value from get metadata. Then we get it up. Now, I like this. This is their answer. It works okay, but I think it's a little wordy. And the reason I think it's a little wordy is because we've got essentially a pattern match with only one case, and we're just using if or else. Now, it turns out that maybe there's some variation in the JSON. Maybe sometimes the JSON has a list somewhere, sometimes it has just a single item somewhere. You can't easily squeeze that into this. So I thought, we ought to use the switch expression version of this, because that'll make it easier to understand alternatives. So this is the answer in the Codelab. Here's my take on it. So the quickest change you'll see is that instead of starting an if statement, I actually go into a switch, and I'm going to be returning whatever the switch returns, which is nice. So we're going to switch again on JSON. Now, one of the things you'll notice right away is that for both the previous version and this version, we didn't go through and alias _JSON here, because we can go ahead and use this in whatever shape it is. If it happens to not be a map with these elements, then this whole thing just gets skipped over. So we don't have to go to the extra step of saying, well, is it a map? Is it non-null? All that's all just shortcutted now. And so I took advantage again of that here. We just do a switch, and here's our first case. Our first case is this little guy here. So there's that same pattern from before. Didn't change it, just copied it from the previous one to this one. Okay, and if that matches, we then select as the output value for this case, we select this title and the modified, local modified, okay? And that then becomes a return value of our switch, which becomes a return value of our metadata. Cool. If there's any other match, or there's no match, then we have this match always here. This little guy, the single underscore, is wildcard. It matches everything. And then what do you know? We just throw the exception directly from there. So this works too. Let me show it by running it. You'll see it's exactly the same output. But the key here is that I used a switch that could have multiple cases and then a final one that says throw with the unexpected value. So we get more like layering here. We can put more cases in real easily. Both of those are functionally the same thing. There's not returning anything new or different with that. So I kind of like that. I'm going to actually have a pull request that suggests that they go and use this expression instead of the other one, because I think it illustrates something kind of nice. Although I think they use the switch expression on the final step of the Codelab. I think that's why they said, no, we'll just do the switch statement here first. Okay, now, but let me go one further. I don't like that sometimes this function returns back the value that we expect, and sometimes it throws. I don't like that. Yeah, and if you've seen in my previous stuff, you know I'm a big fan of fpdart, the functional programming library that sits on top of Dart. And I thought that function is really screaming to be an either as a return value. So I did. I brought in fpdart up here. I changed the value of this function now, of this metadata, to be an either. The left side is an exception. So it's a subclass or it's an instance of something that's a subclass of exception. And the right side, the everything went well side, is our same record that we've been using before. So now, how does it look? Not too different, except that you'll notice that if we have the correct match, we return a right of that. That then squishes it into the right side of the either, and we can detect that back in the top level of the code. We'll go over that in a minute. If, however, we get down to our catch-all branch, we return a left of the exception. Wow, now we have just a simple value coming out of this. The advantage of this is I can actually return more lefts out of the upper code here. For example, daytime parse might blow up. With just a couple more things inserted here, I could make that the kind of parse that would return a left from this slot rather than the right of the value actually working. And that way I would still have parsed this part. I'm still in this branch, but then we can parse this and get the correct value for that. So I could also do that with a when clause. So there's another way to get down to that as well. But there's more than one way to program it, okay? But now we're either going to get a left or a right out of this. We're going to get it as an either. So now we need to do a little bit more work up on the top. I'm going to now get an either of the original metadata. So it's either an exception or a string with daytime modified as a record. And now I need to extract that, so I call .match on it. If it's the left that we have there, we rethrow that. So boom, that's now thrown up and blows up our program correctly. And if it's the right, I just want the right to come out of here and end up in metadata. That makes the rest of the program be the same as it was before. So there you've seen some interesting ideas, interesting ways of putting this stuff together. Now, not in the version that's released as I'm taping this, but in the next version of fpdart, we'll be able to do pattern matching on this either. And we'll be able to say if it's a left, do this, if it's a right, do that, and it will look a lot like code that we had down here for having a pattern match and having associated actions with it. So that's coming soon. I can't use that yet in this demo, but rest assured that very shortly we'll be able to do pattern matching on either type and option type and a couple of other types, I guess, inside fpdart when 1.0 fpdart gets released. All bunch of things change in version 1.0. That's probably worth a whole 4 or 5 shows after this. Anyway, I hope you enjoyed this. Let me run this just to prove that this runs too. Okay, and yeah, okay. Oh, if you want to see what it looks like when it blows up, let's go in and say, just put an extra letter in there. Okay, metadata. Now let me run it, and you'll see it blow up just fine. Let's see, run. Boom. Ah, yes, look at that. We had an exception, unexpected JSON, and we were in that left match. Okay, so you can actually see where we were. We were down in here when we threw that. So there you go, and hope you enjoyed this. Be sure to like all the things and click all the things and tell all your friends about this sequence of YouTube videos. And I'll be back very soon to express some more things about fpdart and Dart 3 and records and pattern matching and all sorts of stuff. Until then, enjoy.